just really continues where we left off. Okay, so we're rolling. So this, just a recap, you will recognize this type of question by it telling you need to fence in a certain enclosure. You got to make an enclosure with a certain amount of fencing available to you. In this case, it was adjacent, it was next to a structure, so there's no fencing required, and I always put it along the long side. That's where I don't place the fencing. For now, I think just trust me. If I have time, I'll explain why you should always do that. No fencing required along that side, so we went ahead and said, okay, let's sketch it. What does that look like? And so there's one long side and two shorter sides. So therefore, my perimeter looks like this. It's basically deducted from that, right? So I kind of, from diagram, went to here. I replaced perimeter with the amount of fencing I had. And in this point, here you have, it's like a fork in the road. Which one should I isolate for? L or W? The answer is it doesn't matter. Both will work. But I will steer you in a direction for a test. I'll kind of say isolate this or that, right? Because otherwise it just gets a bit too messy. So I chose to isolate L. If you can tell, it's the easiest one anyways. And so that is your dependent variable. W is your independent variable. So that's the one we let it be 10, 20, 30. It could have been 100, 200, 300. It could have been 1, 2, 3. It could have been 1.5, 2.5, 3.5. Like it actually can be whatever you want, but we picked kind of like the smart numbers, right? And so there we go. So this was entered, right? This, you chose that, right? You chose that, so keep that in mind. And then what did we do with it? Every single one of these is plugged into that equation up there. So what if W were 10, right? Then the length would have to be 580. Let's just do a little bit of mental math here. Can you handle that? If length is 580, then it stands to reason that those would have to be 10 and 10, right? Because you have 600 meters of fencing available, right? So you should be able to see that's what's happening. So if the sides, if the W's were 20, then 560 is the long side. If the W's are 30, then 540 is the long side, and so forth. Once you have this filled in, you type in, right, area is just length times width, because there is a certain area you're fencing in, right? So we're then just multiplying it, 580 times 10, right? And we enter that into our calculator. But before we do that, is it just me or is it blurry? Maybe I need glasses. Right? Maybe it's a sign. Determine the equation relating the length, right, and the area. So we're going to relate the length and the area. So stat, edit. I have a bunch of stuff there. I'm going to delete that. And so length is here. So 580, 560, 540. L2, don't put 10, 20, 30 in there. You're not going to get a quadratic, right? It's the area. So 580 times 10, 560 times 20, and 540 times 30. Sometimes it looks like it's rounding it, but it's really just showing you the rounded number. It will use whatever you put in there, okay? And then we go stat, calc, 5, and we come up with our equation, right? Stat, calc, 5. We're going to go second 1, comma, second 2, comma, vars, y vars. If you can remember this for next year, you're going to be in a very, very good shape, right? Knowing how to perform a regression. So that is negative 0.5 x squared. That is a must. A cannot be negative. And 300x. And that's my equation. And every single point here is length and the resulting area with that length. We don't know W. There's a way to find out, just like we did with tickets and remember number of items and price. We can just divide and find out. How about I will do that further down. What would be the greatest area that can be enclosed? Remember, area, I'll just do a sketch, right? What's the y-intercept? 0, right? So it's like this, right? So there are those components there, but this point right there will provide you with the maximum area at a specific length, right? It will give you the maximum area at a specific length. So let's go ahead and find that. And this is where your journey begins, right? Like finding the equation is not that bad. Finding points on it is a little harder because you need to figure out your window. So let's go ahead and graph this thing. I think I used it for something else. I'm just going to check to see if L1 is turned on. Yes, it is. So I'm going to go graph. Actually, I should have done something else. I should have done zoom 9, right? But I caught a glimpse of it here. So I'm thinking, should I go zoom 9? If you want to, let's go for it, zoom 9. And it actually went all the way over to the other side and just zooms in on those 3 points. So I'm going to go window, change the X-Men to something negative, right? X max, I couldn't see quite so I'm going to go 1,000. Y min, I'm going to go negative 250 or something like that. Y max, I'm going to go 30,000. And then I will adjust as I need, okay? So if you look at that, hit graph. So not bad. I can't see the vertex, so let's go back to I'm going to go 50,000, something like that. And that does it, right? So watch this, zoom 9 zoomed into this here, and now you kind of changed everything to make room for the whole thing. Second trace 4 for the max. You already found it, I'm sure, because I'm too busy talking, right? And I got, if I round that, I get 300 and exactly 45,000. So greatest area that can be enclosed is 45 what? Meters squared, because we're talking area, right? And that's why it's a quadratic, because it's anything that has squared units means that it's a quadratic relation, okay? So there we have it. And you focused, you didn't just stop there and say, hey, here, this is the maximum area. It's like, well, which one is it? It is 45,000, right? What dimensions would yield the maximum area? Yield is another fancy word of saying would give, right? Farmers use it all the time. Our yield wasn't as high as we expected, right? Like our crops didn't do so well. What dimension? So the length we know already is 300 meters. We know that from here. The length that would give you that maximum area would be 300 meters. The width would be 45,000 divided by 300. Because if you divide, right, if you divide your area by the length, in this case, you would get your width. And what is that? 150? Yeah, it's 150 meters. Dimensions would be 300 by 150. Think about it, right? The length is 300 and both of the widths would have to be 150, right? And that adds up to 600 total, because we were able to eliminate the need for fencing along the other length, right? So there we have. Does this continue? Oh no, graph. Let's skip it. I'm just kidding. We'll do it. We'll do it. So we were supposed to graph length versus area. So no problem. Length in meters. Up here, area in meters squared. So units, right? Area squared, length meters. I know I'm at 0, 0. What do I need to make a graph? I need the x-intercept or intercepts. I need the y-intercept, and I need the vertex. Sorry, you can't see that. There it is. The vertex is already known. That is 345,000. The y-intercept we know is already 0, 0, just by looking at the equation. And so I need to find that other x-intercept out here, right? I need to find that one because I need a scale. I need a scale, right? So 0, y2 is equal to 0. Let's go ahead and find that. It's a bit of a problem. It's blocking, but I trust that it will find it. Enter, enter, enter. So that's exactly 600. Okay, 600, 0. If you, I don't think anybody in here was in pre-cal before, but if you were in pre-cal, they may have done this differently. You need to do it this way, right? Otherwise you'll be in trouble. So let's see here, 100, 200, 300, 400, 500, 600. That would actually work just fine. I will make sure Mr. Dirksen knows where the numbers go, right? So, and that's okay to label every other one. You're consistent. 45,000. So let's see. No, that doesn't work. I will go up by 10, 20, 30. That doesn't work. So 15,000. I'll make every so this is 30,000. You know what? That's cutting it a little bit tight. Let me change that. I will just go up by 20,000. 20,000. 40,000. I just chose to do that last minute. So that means that we're going up by 10,000. The markings would be 10,000 at a time. So let's, this is 300, 345,000. This is 50,000, so 45 is right there. And I'll match that. This should be exact on there. Exactly on the intersection there. And then 600, 0 here. And then voila, right? Let me just check what the there's everything. Boom. 3 out of 3. 3 out of 3. Domain and range, let me just say that it's 0 to 600 for the domain, and my range would be 0 to 45,000. So this was just kind of like take an inventory what you need before you make your graph, right? All right. I'll leave that domain and range up there if you're still copying it. What does it say here? Determine the equation relating the width and the area. I just want to show you that the equation will look different. Okay. Stat, edit. What were those entries for width again? 10, 20, 30. Leave the L2 because it's the same area, right? We're talking about the same area. You're just now choosing to enter the width in for L1. And then I go, let's see, can I use my, yeah, I'm just going to go the cheat, right? Second, I'm going to go to the home screen, second enter, and then just get that. And this is what it looks like. Stat, calc 5. It's negative 2x squared plus 600x. So it looks different, but we're talking about the same area to be enclosed, except for now it's width area. Every single point depicted on this line, on this parabola, will be width area. What is the maximum area? Would it be the same as an E? Yes, right? It'll be the same area. However, oh, it still works, right? So using the exact same window, in this case works. I'm just going to show you second trace 4. I'm just going to show you that. There it is. Enter, enter, enter. And look, 45,000 is still, right? It's 150, 45,000. Max area is still 45,000 square meters. What dimensions would result if width is 150 as per this vertex right here? Then length is going to be 45,000 divided by 150, which is 300 meters. Okay, same as before. Okay, nothing changes. It just goes to show that, right, it's all connected. Regardless which route you take, you should come up with the same dimensions, same maximum area. Everything stays the same. Okay. We will leave this there to be continued. Right? This is to be continued. So I will just stop that there. Maybe all I will say is, actually I lied to you a little bit. There's a homework associated with this section, which is found if you just keep flipping towards the end of that booklet. Like right there is the homework that would go with type 2. Okay. Sure, yeah. So just make note of that. That's your